Hello everyone and welcome back to Kinematics. So today's video will be focusing on this year's trial paper for Negeri Sembilan paper 2, and without wasting time, let's discuss this paper together. First question of section C, coming from solution of triangles, and in this chapter we need to know these four formulas. Alright, so the first two is sine rule and cosine rule. This helps us to find the length of the side of the triangle and also to find the angles of the triangle. Alright, and also for these two formulas will be helping us to find the area. Okay, so here will be the situations where when should we use the formulas. Alright, so for this table, y'all can screenshot it first, because later on we are going through these questions, y'all can know which formulas I'm using. Okay, so for part A1, we are going to find the length of this line, and as you can see, this line is attached to two triangles at once. Right, so if you want to focus on just one triangle, I would say focus on triangle ABE, because there are a lot of information compared to the other one. Okay, so if focusing on this triangle, as you can see, the side that we are trying to find, actually the paired angle is given, which is 42, and also from this angle, you can see that the two sides here, the length is given 12.8 and 5.6. So this is a very clear indication that we should use cosine rule to help us, because here it says two sides. Okay, so two sides here meaning line AD and line AB, because the length of the two sides is given, and the included angle. So included angle means that the angle between the two lines just now, which is 42. Right? So we can use the cosine rule to help us find the line BD. Okay, so a very important thing to note when using cosine rule is these two must be coming from a pair, which is the line BD and the angle 42 here. Alright, so for a small a here, you will need to put BD. Okay, and for the big A later, you need to put 42. Okay, and for small b and small c, we can just substitute the length of these two sides lah. Okay, so these two, they can interchange the places. Either you put 5.6 or 12.8 first. Alright, and here will be 42. So here from the right side, we just simplify and move the square to the other side. Then we will get the length of BD, 9.416. And for part 2, we need to find the angle CDD, which is here. Okay, so we need to focus on this triangle lah. So if you notice, these two are actually a pair, right? And if we relate the 3.9 here, the side and its angle, the angle is the angle that we need to find. So this is a very clear indication that we should use the sine rule to help us, because from the situations here, we need to have one pair, which is this one, the 115 and the 9.412, and also one side, which is the 3.9. Okay, so we can use the sine rule to help us on this. So usually we just look at two fractions lah. Okay, so for the left fraction, I will always put the information that I want to find on top here at the numerator side. So for the a here, I would put sine of this angle, right? Because we are trying to find the angle now. So I'll put it on the left side of the fraction, and I put it at the numerator part. Then the denominator part, I would put the length of the side, which is 3.9. Then on the right side, I will just put the information from this pair. Okay, which is something like this. Then later on, everything we need to move it to the right side except the angle CBD here. Then sine, we move it to the right side. Then we will get two answers. Alright, so how do I get two answers? Is using the ASTC method. Alright, so if you see here, we have sine and it is positive. So we need to find the answers from the first two quadrants. Okay, so for A would be theta and S would be 180 minus theta. And theta comes from the value when we move sine to the other side. Right, which is something like this. Then if we plug this into the calculator, we will get 22.05, which is the theta here lah. And for this one, will be just 180 minus 22.05 to get this value. Okay, so why we need to consider two answers sometimes is because for some questions, it will ask us something like find the obtuse angle of CBD. Okay, so as we know, obtuse is more than 90 degrees. Then we need to accept this as our answer, not this one. Right? So this depends on questions. But here, if we look at the diagram here, you can see that one of the angles is already obtuse. So there's no way in a triangle there will be two obtuse angles. Right? Otherwise the angle of the whole triangle here is more than 180, which doesn't make sense. Right? So we are gonna reject this value and our answer will be 22.05. Alright? And for part 3, we are going to find the area of this triangle. Okay, so I give you all a tip here because let me go back to the formula table. Okay, if you focus on the formula for finding areas, okay, we have two. So one is the normal formula that we use all the time, and the other one is Heron's formula. So Heron's formula, we do not need to use angles, but for the first formula we need. Okay, so in this triangle we have an angle here, so why not just use the first one? Okay, and if you look at the situations when we want to use the formulas, you can see that this formula and cosine rule, the situations are the same. Two sides and the included angle. Two sides 12.8, 5.6, included angle 42 degrees. So we can use back the same information to calculate the area. Alright, so the tip here is cosine rule and this formula, the situations when we're gonna use both of them is the same. Alright, so let us use that formula to find the area. Alright, so 1 over 2 times the two sides, which is 12.8 and 5.6, and then sine 42 to get the area. And for the last part, find the shortest distance from point B to straight line AD. Right, so means B is here, and then we need to find the shortest distance from B to this line AD. Okay, so how are we going to find this? So usually I will always ask students this question, right? So let's say point B is U, right? So you are here and this is point B. So line AD, I will always describe it as the other side of the road. Okay, so here's the road, right? And this is the other side of the road. So this is line AD, and you want to reach here. Okay, so what is the fastest way from your perspective to cross the road? Very simple, right? It's just going straight. Because going to the side, it will be longer, correct? So we always go straight to reach the other side in the fastest way. Okay, so if here going straight will be something like this, right? From here straight to here. So when we are going straight, right, we also notice a characteristic here, which is the direction that you are going to go is actually perpendicular to the line or the route. So here, same thing as well. This line and line AD will be perpendicular, again because the route that you went is straight to the opposite side. So to recap, shortest distance here meaning walking straight. Okay, but our route would be perpendicular to the line AD. So this also means that shortest distance would be the perpendicular distance. Alright, so shortest distance is another word for perpendicular distance. So with this information, what we can do is, this line, right, it will be the height of the triangle, correct? Height of the triangle. So to find the height of the triangle, we can use another formula from area of triangle, which is 1 over 2 times base times height. So area of the triangle we already have, which is in part 3. And the base here we also have, which is 12.8. So by subbing into the formula here, we can find the height of the triangle already, which is actually the shortest distance, which is actually the perpendicular distance. Okay, so we are going to use this formula, sub everything that we have inside here. Okay, so the B here will be 12.8, the area will be 23.982, and subbing inside, find the value of H, which is 3.747. Part B, we need to find the similar triangle where CD, CB, and angle CBD cannot be changed. Alright, so to draw out this similar triangle, we can use the 3-step method. Okay, first step, find the unfixed side. So CD and CB is fixed, so the only unfixed side is DB. Okay, and the second step is to find the unfixed angle from line BD. Okay, so here it says that the angle CBD is fixed, so the unfixed angle would be here. And the third step is, from this unfixed angle, we need to check whether it is obtuse or acute, and we need to, based on the result here, to figure out should we use outside or inside. Okay, so here obviously it is acute because we have already one obtuse angle here. Right, so we are going to look at case number 2, which is we need to draw this triangle to the inside. Okay, so this means the triangle here, for the point D, I'm going to move it inside here. Okay, from here to here, but making sure that the length here, CD, and the length here, which is CD prime, okay, is the same. Okay, because this is one of the conditions here. Alright, and this would be our new triangle. Alright, oh, and also almost forgot, the prime we need to put it here. Okay, because here it says sketch a triangle B prime, C prime, D prime. So all of the points here, we need to put the prime lah. Okay, and for part 2, we need to find the length of CDB, which is from the new triangle here, which is this one. Okay, so how are we going to find this? Well, let me get back to the original triangle first. Okay, so to find this angle, we need to find out this angle first. Okay, and since these two lines are the same, this means that the angle of this one and this one is the same. Okay, so this angle is actually, from the diagram here, is this one. And in this triangle, we already have the angles for these two, so why not, to find BDC, we minus 180 with the two angles here, okay, to get the angle of BDC. And since we know that the angle of this angle already, and this angle is the same, then to find this one, B prime, D prime, C prime, we just 180 minus the angle here, which is 42.95, okay, to find out our answer. Question 13 focuses on kinematics of linear motion, and this is the last chapter for the Form 5 syllabus. Alright, and also in this chapter, if you notice, there will be some keywords that we need to do some certain actions, right? So what I did here is I compiled all the keywords that we need to know, and I also written out the actions that we need to do for each of the keywords. Right? So you can screenshot this table and you can use it for revision purposes. So if we go back to the question here, it says the particle moves along a straight line as usual and it passes through a fixed point O. Okay, but the special thing is it has a velocity of 36 meters per second. Okay, this means that when the particle passes through the point O, so means when the experiment begins, this particle has already have a velocity, already has a speed. Okay, so this means when t equals to 0, when the experiment starts, when the particle passes through this point, it has a velocity of 36. Right? Then for the next sentence, it gives us the acceleration equation. Okay, so this is not much to highlight. Okay, and in the last sentence, it says the particle stops at k seconds. Okay, stops here, we have a keyword in this table, which is this one. Alright, and our action that we need to do is to put v equals to 0, means the velocity or the speed is to become 0. Reason is because it stops, right? Not moving. Okay, so here means that when t equals to k, then the v is equal to 0. And for part A1, we need to find the maximum velocity of this particle, and maximum velocity is actually one of the keywords in this table, as you can see the last second row. So this is the action that we need to do, which is a equals to dv over dt equals to 0. But what does this mean? Right? Some of you may ask. So let's go back to the question here, and if, as you know, this chapter actually heavily relies on differentiation and integration. So we can view this question as a differentiation question first. Alright, so usually when we want to find a maximum of something, what we need to do is to find the original equation first, which is the velocity equation. Okay, and then we differentiate in terms of t. Okay, again, this chapter also heavily relies on the value of t, which is time, so I put dt here, okay, instead of dx. Right, and then once we differentiate already, then we need to equate it to 0. So that's the standard procedure when we are finding maximum of something. Okay, right? So now the issue is we don't have the velocity equation. We only have the acceleration equation. Right? So let's recall back the relationship of relating s, v, and a using differentiation and integration. So as we know, if we want to go from s to v to a, we need to use the differentiation way, right? And if we want to go back, would be using integration, right? So if you look at these two diagrams here, as you can see, if I differentiate v, I get dv over dt, and here v, if I differentiate, I get a. So this means that if I differentiate v, and these are the two results I get, technically these two are the same. Right? That's why in the table you will see that here is a equals to dv over dt. And because I'm finding the maximum velocity, then I need to equate it to 0. That's why it's here. So we can use this to find the maximum velocity of the particle. Right? But there's a thing we need to know. So questions in this chapter, right, we cannot straight jump into finding the maximum velocity. We also need a thing, which is when does this happen? Okay, so to find when does it happen, then we can use the equation here. Okay, so this dv over dt is technically a, so we can use this equation first. Okay, and then we find, okay, we change a to dv over dt, and then we change it to 0 because we are finding the maximum velocity, right? And then we rearrange a bit and we get t equals to 5 over 2. So this technically is not the velocity, this is the time when this maximum velocity happens. Okay, so whenever we want to find like the maximum velocity, the displacement, the speed, what we need to have first is to figure out when does it happen. Okay, which is the t here. Okay, so now we have the t already. What we need to do is just to substitute this t into the v equation to get the maximum velocity, right? But the issue is we don't have this, so what we can do is we use the acceleration equation, integrate to get the velocity equation. Alright, so here we just add 1 to the power and divide with the new power. The 5 we add a t to it, so it will be something like this. Okay, and here there's no range, so means at the back we need to add a c. Okay, and how do we find the value of c is we can actually use this information, where t equals to 0, v is equals to 36. Right? Reason is because if you imagine this part, if we substitute 0, technically everything will become 0, and if we substitute 36 here, technically this equation means c is equal to 36. Okay, so this would be our velocity equation, and now what we need to do is just substitute the t inside this equation, right? And this would be our maximum velocity of the particle. And for part 2, we need to find the value of k. So k here we can find it through this information here. So the velocity will be equal to 0 if t equals to k. So what we can do is we use this information, substitute into the velocity equation here. Right? So velocity equals to 0, then the t all become k. Right? So here the front value is a negative, so let me change all the values from positive to negative, negative to positive. Right? And then you can see this is a quadratic equation, so I can use the calculator to split it into two answers, and my two answers would be k equals to 9 and k equals to -4. Okay, so here we need to reject one of it, which is this one lah. Okay, reason is because k is actually time. Time cannot be negative. Alright, so our answer is k equals to 9. For part B, we need to sketch the velocity time graph for t from 0 until k, which technically is 9. Alright, and we need to calculate the total distance traveled by that particle. Right, so a very important thing to note for velocity time graph is once we draw the graph of the curve already, the area under the curve or the area under that graph will be the total distance traveled. Okay, so let's draw out this velocity time graph first. So here the x-axis would be t, y-axis would be v, and let's draw out our starting point for velocity. So we know that here, when at the start of this experiment, when t equals to 0, the velocity is 36. Okay, so let's plot our starting point first. Okay, and then this particle will reach a maximum velocity at this time, right? So 5/2, and reach the velocity of 42.25. So we'll plot a point here also, right? And then it stops, right, which is when t equals to 9. So my endpoint would be here. Then I join the 3 points to form the velocity graph or the velocity curve. Right, so just now I've mentioned that to find the total distance traveled, we need to find the area under this graph or curve. Right, so what we need to do is just use the integration way. Right, so here we need to integrate the velocity the velocity equation, and we need to differentiate in terms of dt, right? Because everything here is in t. Okay, and for the ranges here, we need to integrate from 0, which is the starting point, until the ending point, which is 9. So now it's just normal integration. So now these two values I sub inside here and find the differences to find the total distance traveled, which is 283.5 meters. Question 14 focuses on index numbers, and I would say in general for the questions in this chapter, we need to take note of the years given. Okay, so sometimes they might give us a lot of years and then we will confuse. Right, so here the years given would be 2012 and 2010. Alright, and also in this chapter, we will always use these two formulas only, which is also given in the formula sheet, which is the price index and the composite index. Alright, so in part A, we need to find the value of x and y, which is the two values in this table. Right, so x here is the price index and we need to use this formula. Right, but let's understand this formula a bit. What is P1 and what is P0? Because sometimes a lot of students will mix up these two values. Right, so P1 here is called the specific, P0 is base. Right, so a very simple example, let's say specific is you, okay, you yourself, and you want to know whether you are taller or shorter. Okay, let's say so to decide whether you are taller or shorter, you need to have someone to compare with you, right? So that someone is your base. You need to have a base to compare, so you'll be able to know yourself whether you are taller or shorter. Right? So same goes to here. Okay, as you see here, it says price index in the year 2012, which is us, and based on the year 2010. So this is the base that we need to compare to. Okay, so for the price that is us, which is 2012, we need to put on top, which is the P1, and for those prices which are our base, for the 2010 price, we need to put at the bottom. Okay, so using this formula, I would be x, P1 will be 2.16, P0 will be 1.8, and then we put this multiply 100 here to get the price index or the value of x. Okay, same goes to this one as well. Putting these three values inside this formula, then you'll get the value of y, which is 2 ringgit. Part B, we need to find the value of m if the composite index for the year 2012 based on 2010 is 123.8. Okay, so since it says composite index, then we need to use this formula. Okay, this is the composite index symbol if we use 2012 based on 2010. So here I just put 12/10, right? And then here I multiply the price index, which is 120 with 4, and then add with 130 times 3, and so on. Okay, and for the denominator, it's just adding up all the weightage. So 4 plus 3 plus 1 plus m. Right? And once we have this ready, then we can substitute the composite index value, which is 123.8. And then we simplify the right side and find the value of m. Okay, so we can move this to the left side and move everything with which has m to the left side. Okay, and then we will get the m value, which is 2. For part C, it says that the price of the beverage will increase 30% from 2012 to 2015, and in part 1 we need to find the composite index of that beverage in the year 2015 based on 2010, right? So this is the composite index that we need to find. So usually for composite index, one of the ways is to use other composite index to find the composite index that we want. So usually we need to have 2 of them, right? So one of the composite index, we can find it in part B, which is this one, alright? And another one, we can find it here actually, because here it says that the beverage, right? As we know, the beverage here includes all of the ingredients here. It's similar to composite index. We include all of the individual index and the individual weightage, then we combine them together. So similar to beverage, which includes all of the ingredients. Okay, so now the issue is we only have the percentage. We don't have the price form. Sorry, the price index form. So just a general knowledge for price index, if it is 100, means the price does not change. Right? If it's more than 100, means the price increases. If it's less than 100, means the price decreases. Right? So now it says it will increase by 30%, so means it is more than 100. So if you want to change this percentage to index, very simple. It's just 100 plus 30. So our index here would be 130. Alright? And another thing to this index is it is based on or from the year 2012. So this is the year that we need to compare with, and this is us. So our year would be 2015 and we need to compare with 2012. So our composite index would be 15/12 will be equal to the price index. Okay, so now we have the other two composite index, then we can find this index using a shortcut in the BI version and the BM version of the textbook in page 275. Right? So the first step of this way is to rearrange the years from the latest to the earliest. So the latest would be 15 and 12 and followed by 10. And then we are going to use the formula of price index, so meaning P1, P0 and I, we are all going to change to composite index, okay, which is something like this. So from the left side, we are going to put the two latest years, so it's 15 and 12. So here we are going to put 15 and then /12. Alright, and for the right side, we are going to split these 2 years. So 15 we're going to put on top, 12 we're going to put at the bottom. And the empty space here, which is the base years, would be the last year, which is 2010. So recap, put the 2 latest years here, and you go to right side, split them, and put the last year that we haven't used. Okay, so now very simple, we just need to substitute all the information that we have into this formula. So 15/12 will be 130 and 12/10 will be 123.8. So we rearrange and we'll get the composite index that we want, which is 160.94. And in part 2, we need to find the price of the beverage in 2010 if in 2015 the price is this, 3.46. Okay, so again this is beverage, so we need to use the composite index and it needs to relate the year 2010 and 2015, which is the composite index that we have found just now. Alright, so since we are finding the price, so we can use the first formula, the price index. But you see that we are using the composite index instead of the individual index. Okay, again, because the beverage includes all of the ingredients, right? So all of the ingredients, I need to use the composite index, not the individual index based on the ingredients. Okay, so here we can just substitute the information that we have. So the composite index will be this one, and the price for 2015 is 3.46. So to find the price in 2010 would be 2.15. And our last question coming from Linear Programming chapter. Okay, so here we need to seal 2 things. One is the baju kurung and the other one is the baju Melayu. And in this table we have the preparation time and the sewing time. Okay, so let's identify what is X and what is Y first. So here it's baju kurung will be X, baju Melayu would be Y. Right, so in part A, we need to write out the 3 inequalities as usual. So to form equations or inequalities, I will always use these 2 to help me form, which is total and comparison. So let's find the examples in the question here. So our first sentence, it says that the maximum preparation time, or meaning the total preparation time that we cannot exceed, is 100 hours. So this is example of total. Right? So from the table here, let's find the total preparation time. So it's 50 multiplied with x plus 75 multiplied with y. Right? And then we cannot exceed this value, which is 100 hours, but as you can see, the units is different, so we will change the hours to minutes, so we will multiply 60 to get this value. Okay, and this would be our first equation. So the total preparation time from the table, and then would be less than or equal to the 6000 here. And for the next one is minimum sewing time, so meaning total sewing time that we need to exceed. So this is also example of total, right? So here we just find the total sewing time from the table, so 50 multiplied with x plus 60 multiplied with y, and then we need to exceed this value 50, or we change it to minutes, would be 3000. Okay, so our second inequality would be something like this, and the inequality here would be greater than or equal to, because we need to exceed this value. Alright, and the last one, as you can see here, the ratio of baju kurung to baju Melayu must be at least 1 to 2. Okay, so this is an example of comparison. We are comparing the value of, we are comparing the number of baju kurung to baju Melayu. Okay, so if we write this in mathematic form, it should be x to y is at least 1 to 2, right? But this one, we can also change it to the fraction format, so which is x divided by y would be at least 1 to 2. Okay, so this would be our third inequality. Right, so here we can go to part B, and let's go to the whiteboard to solve this question. And for part B, we are given the scaling for x-axis and y-axis, so it will be something like this, right? So one big box for x-axis would be 20 pairs, and for y-axis, one big box would be 10 pairs. So it will look something like this, right? And now, according to the inequalities that we have formed in part A, we need to sketch the lines and we need to shape the region R. Right, so it will be something like this. Hopefully yours is the same as mine. And here another thing I think students forget is to label the lines lah. Right, so all of the lines we need to label it, and we need to make sure that the equation here must be equal. Okay, reason we need to put it as equal is because we are drawing the line only. Okay, so please do not put inequalities, please change it to equal sign. Again, because we are drawing the lines only. So to sketch the shaded region, we need to look at the position of y. So meaning, if y is on the lesser side of the equation, then we need to sketch downwards. If y is on the greater side of the equation, we need to sketch upwards. So what is lesser and greater? So for example, this equation, as you can see, y is less than 6000. So this means it's at the lesser side of the equation, which means we need to sketch downwards. Okay, so going back here, let's find the equation for the inequality, okay, which is this line. So later on, we need to sketch downwards. Okay, for this one, y is on the greater side, so means we are sketching upwards. So for this line, we are sketching upwards. Okay, let me put an arrow here. And then for the last one, okay, this one we need to rearrange a bit because y is at the denominator side. So if we change this y to the other side, so it will be x greater than or equal to 1 over 2y. Right? So as you can see, y is on the lesser side of the equation. Sorry, of the inequality. So this line, we need to sketch downwards. Okay, so to find the region, let's find all the regions that we have in this diagram. Okay, so we have 1, 2, 3, 4, and 5. Okay, and we need to eliminate them one by one according to the 3 conditions that we have here. Okay, so let's go through one by one. Alright, so for the first line here, we are sketching downwards. Okay, we need to look downwards. So the things above it, we need to ignore. For example, this one. Okay, so this is for the first line. The second line is we need to look upwards. Okay, so everything which is below it, we need to ignore, which is these two. And for the third line, we need to sketch downwards. Okay, so everything above, we need to ignore. For example, this one. Okay, so the remaining region would be this one. And this would be our R, or our shaded region. And then we just label R here. For part C, it says that the profit for Baju Kurung and Baju Melayu is 70 and 120, and it says that the maximum profit is K. So we need to find the objective function, which is also K in terms of X and Y. Alright, so objective function here just means that we need to form an equation according to the aim of this question here, or the objective of this question here. So the objective here is just to find the maximum profit, right? So we just need to form an equation to find the profit. So very simple, just 70 multiplied with X and 120 multiplied with Y. Alright, and in here it says that objective function is K, so this part I just change it to K, and this would be our objective function. Okay, so let's continue this question, and it says that hence, using the graph in part B, we need to draw the objective function and we need to find the maximum profit. Right, so to draw the objective function, we can use this equation, right? But here there's an issue because there's this K. K can be any value here, right? Which is also a good thing for us when we are drawing the line. So since we do not know the K, so for the equation later we are going to draw, for the right side we can put any value. Okay, any value. But here I would recommend to multiply the two values that we have here to form the number on the right. Okay, reason is because when later we are trying to find the x-intercept and the y-intercept, it will be easy for us to find the 2 points and then draw the line. Okay, but sometimes the number here can be quite big, and then the objective function you are going to draw later would be very large, which we don't want. So we cut off a 0 to make sure that the line that we are going to draw later is small at the side. Okay, so later I'll show you what is small and what is big. Okay, so I will cut off 1 0, and then to find the x and the y intercept, okay, with these two, and then I draw it in the graph. So using the x-intercept and the y-intercept, this would be our objective function, and make sure to draw it in the formula. Okay, and as you can see, it's at the edge of the graph. So if let's say we did not cancel off the 0 that I mentioned just now, you can see that the objective function is this big. Okay, so usually we will avoid to draw the objective function in this way lah. Okay, so we should always draw at the edge of the graph. Right, so now to find the maximum profit, we need to find that point that helps us to find that profit. Okay, so what we can do is use the objective function. Okay, use the objective function. So what we need to do is just push this objective function or this line upwards until we find the last point that this red line intersects the region R. Okay, so it's here. As you can see, it does not intersect any points in region R except this point. So this point helps us to find the maximum profit. Okay, so the x value from here, if we go downwards, is 30, and from the left side here, the y value is 60. Okay, so our coordinate is 30, 60, and let's go back to find the maximum profit. So we have found out that the maximum point is 30, 60, so we are going to substitute the two values inside x and y to find the maximum profit, which is 9300. And with that, we have completed the discussion for this paper. Alright, so thank you so much for watching this video, and I apologize for the delay for the paper 2 discussion because I was sick during the process of making the video, so apologies for that. Okay, but if you have any questions regarding the paper here, feel free to put in the comment sections below. Okay, for the next paper, I'm not sure which paper I'm going to discuss, so if you have any suggestions, you all can also put your suggestions in the comment section lah. Okay, so thank you so much again, and take care, and I'll see you all in the next video. Bye bye.